Hey folks, Quill18 here, and welcome to a brand new Unity tutorial series about hex tiles. We have done some videos on hex tiles in the past, but it's one of the things I get tons of requests about to do more work for. People are asking things for like, how would I make a cylindrical world map? How do I add more of these classic 4X elements, more like cities that you can create units from, units that move in more of a turn-based way with like the turn-based mechanic really being established in there, really integrating pathfinding in there, maybe some rudimentary combat, maybe looking at things like technology system and buildings for the city, that sort of aspect. Classic 4X tile game stuff. And so I thought, okay, let's go ahead and do this. We'll make a bigger, longer format tutorial for the mostly civilized Hex engine. And it's also a really good opportunity for me to redo a hex tutorial using some great information that I ran into on Amit Patel's page about hexagonal grids. Amit Patel is someone who has done a lot of like tutorials in the past, like back from on a Stanford student site. So not tutorials so much as like introductions or discussions of a large variety of programming techniques, which are really handy. And in particular, he's had one for a while for hexes, but at some point it got updated with this cubic representation of hexes, using this cubic math system, this cubic coordinate system to represent hexes that just like blew me away. Like, oh my God, this makes it so wonderful to work out so much of the math. He calls it here, this is a weird idea, but it helps make the hex grid algorithm simple. And it does. It's going to be one of these things. I'm going to link this page down below. Read it. First of all, this website is like gorgeous because like as you like click on things, it like changes the representation of data on the fly, so you can compare things. Would you prefer flat topped hexes versus pointy top? And like notice how all that like the text changes to like show you that. Oh my God, what a gorgeous website. Anyway, it's gonna be linked down below. But this apparently this idea of cube coordinates first came up in the mid '90s on a programming forum. He's got credits listed down below for where he first saw this. Yeah, right over here. This is Charles Fu. He posted to a programming news group, and anyway, it's fantastic. I love the idea that like some of this stuff is still sort of kind of being figured out in weird, bizarre ways. So that's what we're going to implement here. It's going to be really, really wonderful. I'm very convinced that this is going to be a strong way to go. So I'm going to link to that down below. But let's get started. So what I've done here is I've set up basically an empty project in Unity. We're going to work in 3D mode. And I have gone and produced real quickly in Blender just a simple model to use as our hex tile. We will investigate different options for generating these on the fly or changing them on the fly. Just for us to get started, I just made a simple hex so that we've got something to play with at the start. If you go and follow the link down below to the project page, which is going to be on GitHub, you don't have to download the whole project. You could just download this hexmodel.blend file, and that will be sufficient to get you started. So what we're going to do, obviously we're going to need, do a little bit of coding. We're going to have to add something in. The way I want to structure this is I want to create an empty. Okay, and this empty, I want it to live at 0, 0, 0. Not that this part is incredibly important, but it's usually a good idea to get everything centered over. And this I'm going to call something like hex map. Like this is going to be the thing that represents the entirety of the map that's going to be on the screen. And I think all the actual individual hex tiles. Now I've talked about before the idea of having one giant object versus multiple little objects, pros and cons. In this case, we are going to, at least for our first pass, we are going to have each hex be its separate game object. And there's going to be a few different reasons why we're going to do that, but we're also going to look at ways to optimize that kind of behavior. Because I've talked about before, it is much better to render a single very complex mesh than multiple simple meshes, because the biggest overhead for rendering an object is each object itself, as opposed to the number of triangles. So it's better to have minimal objects, even if they're individually bigger. And there are ways we can do that, but there's also all kinds of ways that we can take advantage of batching and stuff in Unity to actually minimize the draw calls in the end. Anyway, so we're going to have this hex map object, and I'm going to want to have a component on it, and I'm just going to call it hex map. It's just going to be responsible for creating and managing the map. It'll probably interact with some sort of, like terrain generation system later on to make maps that are Pangea style or continent style or something like that. We'll look into implementing some of those. To start off with, it's just going to create hexes in general, just untextured, unpretty hexes just to get us started, just flat hexes. All right, so we'll load this up. Excellent. We will go ahead and embiggen this. I don't think it'll need an update. Maybe later, maybe we'll think of something. But really what we're going to have is we're going to have some sort of function, public void generate map, I guess, to start off with. That's perfectly fine. And we're just going to call that and start. Maybe later on we're going to want to call this through some other method, but for now it's okay that it just runs on start. And so this thing's job is going to be to generate our hexes, okay? So imagine we're going to make, our first map is going to be, I don't know, 10 by 10. Okay, so that's going to be 100 hexes. And it's like, okay, so we're going to have, let's say we make a for loop. So for x is 0 to 10. And inside we'll have another for loop, which is going to be y is 0 to 10, right? That sounds fine. And then we will make hex. So, okay, let's make a hex. So instantiate a hex. So that sounds to me like, well, unless we have a function to generate the mesh on the fly. But even then, we don't have to generate the mesh once and we could reuse it. And anyway, we're really going to have a public game object, which is going to be our hex prefab. Seems reasonable, right? Some sort of hex prefab over here that we are going to then instantiate. Well, I suppose I could, let's finish this code. Instantiate hex prefab. It needs a position. So let's imagine for the moment that we're going to create this object that say, we'll use this x. The actual world space y, we're going to leave it 0 because we want the ground to be at a y of 0 because positive y means higher. So we're going to leave that there, and we're actually going to pass the y as that thing. So you know what? Let's change this representation right away. Instead of using x and y, which we might confuse with our world space x and y, let's rename this to something like column and row. I think that's going to be much clearer. So we're going to have a column and a row, and we're going to use that as the coordinates. These are wrong. These are not going to be correct, but we're going to use that to start off with. We're also going to need to pass in a rotation, and because it's required. If we're calling the version of instantiate, which takes in a vector, it is going to need a rotation. So usually we're just going to say quaternion.identity. This means no rotation at all. Okay? And then what we're going to do is, just to keep things clean, we don't have to pass this fourth parameter, but the fourth parameter is the parent of this newly instantiated object. So I'm going to pass myself. I'm going to pass the hex maps transform as the parent of these new hexes. And that's going to keep our grid here very, very clean, because everything will be a child of hex map. Apparently I missed a semicolon. Oh, indeed I did. Boop. No, not there. Here. Boop. And go back. All good? All good. Excellent. So, our hex map script is expecting a prefab over here, or it's not going to be happy when we try to run. We'll get a bunch of errors. That's fine. So we need a prefab. So let's make one. Now, we could just take our model and drop it into the world here. So this is, we took our mesh, dropped it in here. This automatically makes a game object for us and everything like that. Then we could go and let's make a prefabs folder. Right? Let's say I take this and then drop it in here. So now I have a prefab hex model. And so let's say I then, let's delete the one I put in the world. We don't need that there anymore. So our hex map, let's give it this hex model prefab like that. We're going to get several things that are not going to be right here. Let's hit play and see what these several things are going to be. Well, okay. So here's our objects, which we're having a hard time seeing because of the lighting situation. Let me go and go into shaded wireframe. There we go. That'll be a little easier to see. So we have many hexes, but for some reason, they're standing up on end. Now let's take a look at our inspector here, our hierarchy, right? Our hex map has a bunch of children. Each one of these are in here. And here's a thing, and I've talked about this many times before. Each one of these has a position, and they seem to be offset in sort of a grid-like fashion. I guess that's fine. Notice that they have no rotation, which makes sense because we told it to spawn with no rotation, quaternion.identity. But as it turns out, my model here, because it's a model that I brought in from Blender, it actually needs a negative 90 rotation along the x-axis to be properly flat. Okay? And this is very, very common for your coordinates in your different programs, Unity and your modeling programs, to not be the same basic coordinate system. Or maybe you modeled something standing up instead of being flat. Or maybe you modeled something too big, so you're having to like scale it down when you bring it to Unity so that you're happy with the representation. All those things mean that they can go away when you instantiate it. If you were just to use the prefab or the model directly on the root of the prefab, which is what we did here, right? The model, the mesh renderer over here and the mesh filter are on your base object. Never a good idea. It's also a pain in the butt later on if you decide to change what the model is, especially if it's more complex, if it has more than one part to the model. It's a big pain in the butt to change everything. It's always, always, always going to be much better. Create an empty. We're going to call this the Hex Prefab. Okay? Empty. I'm going to make sure it's at 0, 0, 0. And put your model or your graphics and everything like that inside of your empty. In fact, you can put all sorts of things. You could create, say, inside of this, you could create another empty. This could be like your, your collision info, your collider info. This could have your, I don't know, your sphere collider or whatever it's supposed to be. All underneath the master object over here. Avoids so many problems, lets you work with things much better. It's going to be great. So I'm just going to make sure that the hex model is at 0, 0, 0 inside. The model is going to have that rotation, that negative 90 rotation, but the prefab itself has no rotation. Same thing if I needed to scale things like ahead of time because I made my model the wrong size. I would scale the model, but leave the prefab untouched. I mean, in-game stuff might decide that this model, that this prefab game object would have to get scaled, but that's different. If the model itself needs tweaking, you update just the model ahead of time, and there you go. So I'm going to take this hex prefab object, drop it in the prefabs list. I'm going to get rid of that old hex model prefab. So there we go. So now we've got this. I'm going to delete the one that's in the game, and hex map, I'm going to make sure you're now pointing to the hex prefab. So that's one problem dealt with. Let's hit play. Okay, so I mean, now they're flat in the correct way, but they're obviously not positioned correctly. Now, because the reason is they're supposed to be slightly offset. Every other row is supposed to be offset by some amount, but even the vertical spacing. Oh, sorry, I'm looking at this the wrong way. No, well, it's fine. Even like the spacing here isn't quite right. Like it's like we're really not where we were supposed to be, because this is where we want to go. We want it to look like this. The problem is when you're looking at it here. So let's figure out, let me drop you in here. Let's talk about the dimensions of a hex over here. The center point of the hex, we can think of this as a little bit of a circle, right? This hex, you can think of it as having a radius from the center point to the pointy end. In our case, we have flat sides, pointy top. You could, of course, if you wanted to, you could have pointy top, or sorry, flat tops, pointy sides. But most 4X games, I think, tend to do flat sides, pointy tops. In any case, the center to the pointy end, that's kind of your radius. You can see here, it's basically a radius of 1. Its full height, its full diameter would be a 2, because, you look at the grid, right? This is a distance of 1. So it has a radius of 1. But from the middle to one of the sides, it's slightly less. It's not quite 1. Which makes sense. I mean, otherwise it definitely wouldn't be a right kind of hex. So there's like weird sizes like that. And in addition to the fact that those dimensions are a little bit weird, so to put the two side by side, the one to the right here is not quite 1 unit over. It's 1.738, or so it's not 2 units over. It's not its diameter over. It's 1.738 units over in this particular case. Yeah, that's true. And not only that, if we were to put one above here, so let me set the X to 0, right? So we could give it a Z offset of 2, which is about the height here, but that's obviously not where this hex is supposed to go. It's supposed to go here, which is offset in the X direction by half as much as this one, and then some amount vertically, which is how much? As it turns out, it's 3/4 of the height. Much, as it turns out. But upwards. So it's like, oh, okay, so that's not super clear. Now, in the past, what we've done is we've put all the math in here. So we've got some sort of column and some sort of row, and we want to convert that to Unity world space, and we're having to do all sorts of awkward math, especially when we get this sort of zigzaggy pattern on the side, right? Because like, are all 4 of these in in column 0, right? Because it goes row. This is row 1, row 2, row 3, row 4. That's fine. But then this would be column 0, column 0, column 0, column 0. So this would be the coordinates of this one you could call 0, 4. Okay, but then you have to, yeah, so every other row gets offset by a half and an amount. It starts to get a little bit awkward. You're having to do modulo operations. You're having to check evenness or oddness of rows. Finding neighbors later on is really a big pain in the butt. That was the approach we've taken before. The whole thing with this cube coordinate approach is that while the idea of working with cube coordinates may not be super intuitive, the math comes out to be super clean. Super clean. And that's what we're going to do. So what we're going to do is we're actually going to make a helper class here. So this hex map is still responsible for spawning everything. But we're going to make another class over here, which is responsible for holding the definition of a hex. So we're going to have a class called hex. And this class's job is, first of all, it's not going to be a mono behavior. It's going to be a pure C# data class. Okay? The Hex class defines the grid position, world space position, size, neighbors, etc. of a hex tile. However, it does not interact with Unity directly in any way. The closest we're going to get to it is we'll have a function in here that returns a vector 3 to define the correct world space position of this hex. But that's it. It's not going to know anything about game objects or anything of the sort. Now, when you are using cubic coordinates to describe your hex, instead of having like just a column and a row, right, an X and a Y or something like that for your hex, you actually have 3 numbers that define the cubic coordinates. So this hex would need an X, a Y, and a Z. However, I'm going to follow Amit's lead, and instead of calling them X, Y, and Z, I'm going to call them Q for column, R for row, and S for like a sum value. So column, row, and some extra value. Some. Now, we could treat this almost like a struct and just have like public int, Q over here as a field. We could also have it as some sort of property, right? I could say, oh, it's your public getter, but a protected setter, so that no one else can change this thing. That's fine. I think for our situation, though, I can't see any reason why the value, the Q, R, and S of this hex would ever change once a hex is created. A hex should never change its position in the grid. It makes no sense. It might change its position in the world because we're going to be doing cylindrical wrapping of the map. That's different. So let's use, and this is something I rarely do, let's use the read-only keyword over here. What this thing does is it means this value can only be set once during the constructor. So we're going to have the Q and R. So again, this is going to be column, or something like that. I don't know why Amit used Q as opposed to C, but I'm just going to follow his lead. And then S, some sum factor over here. Okay? Some. Now, again, to create a hex, you need those 3 values. Okay? You would sort of need to ask for the Q, the R, and the S. But there's something very interesting that happens here. The value, when you have a cubic representation of your hex, Q plus R plus S must equal 0. That's just the way the math works out. This Q plus R plus S ends up being 0. So you always have negative values and things like that. I mean, your initial hex is probably going to be 0, 0, 0. But after that, your next one might be 1, 0, minus 1, for example. They always come out to be 0, which means that you can say that S clearly must be equal to the negative of Q plus R. If this is the case, like if these have to be equal 0, then this also has to be true. Therefore, we never actually have to ask for the value of S. Instead, we can say, okay, this dot Q is equal to Q. this dot r is equal to r. And finally, this dot s is equal to negative q plus r, like that. So again, these are read-only values, but you can set them in the constructor, and that's it. These values are now locked in. They cannot be changed again, and that's totally cool. So the nice thing about this is we don't have to think about s. We can still think of this in terms of columns and rows, but as we're going to find out, these columns aren't going to be exactly the columns you might expect. That's okay. So we got this. I mean, that's part of it. Now, so the idea is in our loop over here, we can be like, okay, so we're going to create a hex, H, a new hex, and we're going to pass it a Q and R. So we'll pass it, say, the column and the row. That's good. But now we still need to get the position. What we'd like to do is be able to say H dot, say, position. Right? Take our hex, get some sort of position value for it. That's 90% of the reason we're constructing this class. So let's make a public function that returns a vector 3. So again, a little bit of Unity-ish in here, but vector 3 is a great data value or data format for us to send this information. It returns this, and it's going to be called position. Position, if I can spell at all. So this will returns the world space position of this hex. Okay, so we'll just return a vector 3 with some sort of values. Okay, something. But what? Well, I'm going to tell you, like, so the question is, like, x, question mark. The y is just going to be 0 because we want everything to be flat at ground level. And the z component is going to be 1. We don't know that aspect yet. But it's not too hard to figure out. So first of all, we're going to have some value for the, well, effectively that radius of the hex. Okay, again, it's not truly a radius, but it's sort of kind of a radius. Let's have a float for radius. And I guess this could be a value that gets passed in over here. For now, let's assume that we're just going to have a radius of 1, right? If we figure from the midpoint of our hex to the pointy end, it's going to have a radius of 1. I think that seems relatively fair. We might make this a property of the constructor or something later, but for now, let's just go with this. That means the total height, right, from top to bottom of this object is going to be the radius times 2. I mean, the other way to think of this is, yeah, this is the diameter, but height's going to be fine. Because we also need to know the width, because the width and height are going to be different, right? So if we go back in here, again, the height from the midpoint, so the radius of the midpoint to here, so obviously the height is twice that much, but the width is a little different because it doesn't go as far, it doesn't have that point. So how much is it? Well, luckily, someone else has figured out the math for me, which is good, because obviously that's always a bit of a shortfall for me. As it turns out, it's the square root of 3 divided by 2 multiplied by the height. Now, we're going to save ourselves. We don't want to do a square root in every single loop. So what we're going to do is we're going to store this value. Just for proper form, the constructors come first, then the public fields, and then what we're going to have is we'll have a constant field in here that is just like the width multiplier, like this. So it's constant float, which is going to be set to this, just so that we don't have to do this square root operation every single time we do position, because otherwise it would be quite slow. So we're going to do that. That's all legal, right? To set up the constant like that. The expression must be constant. Okay, so it's not happy about this. If we set this as a read-only here, I don't know if we'd be able to instantiate it then, or we have to do it in the constructor. Okay, no, it's happy with that. Excellent. So we're gonna set up the width multiplier one time. You can even set it as static. Literally one time. I don't want to have to do that math more than once. Excellent. Okay, so at the start of your program, width multiplier will get calculated. Hell, you could literally pre-calculate this value, you know, on your calculator and type in the correct number, but this seems like a pretty okay thing. So there you go. So this width multiplier, which happens to be the square root of 3 divided by 2, multiplied by the height, gives you the width of your tile. Excellent. So that's not what we need to use, though. What we actually want to know is the spacing. So the horizontal spacing between tiles, between hexes, right? How much is it? Well, for width, it's actually simple at this point. We literally want to move over. So whatever our width is, we want to offset by exactly that much. So the same amount of width. Whatever this number comes out to, which it turns out is about 1.73, which is the width of the entire hex, that's how much we want to move over by. So the horizontal spacing is easy. It's the width. The vertical one, not so much though, because we aren't offsetting by the height. We're not offsetting by the total height. We are offsetting by this much. I mean, we also happen to, no, not that much. There you go, this much. So we're offsetting by this much over here. And also going to the right. But clearly this is the correct amount of vertical spacing. This is the correct amount of vertical spacing between each hex. And as it turns out, that value, float vert, is simply equal to the height multiplied by 3/4. That's it. That's it. To save, I think the compiler is smart enough to do this ahead of time, but just in case, we will pre-calculate that. So it's 75%. It's 3/4 of the height is the correct amount over here. So then what we can do is now we can return something. So the horizontal offset, well, actually, let's do the vertical offset first because it's actually slightly simpler. So the vertical, or Z offset, is going to be vert multiplied by, whoa. Oh yeah, the autocomplete is a little bit broken because my code is not quite set up. But it's going to be the vertical spacing multiplied by what row we're in. The horizontal part is going to be the horizontal spacing multiplied by a combination of what column we're in plus half of our row over here. Okay? So the reason for this is our horizontal spacing, if we look over here, right, is going to be this much if we're on the same row. But if we're offset, it's going to be at half of a horizontal aspect. So these here are all being offset from half of the previous one, even though, and this is going to be the confusing part, these are all in the same column. This is all going to be column 0. This is also column 0. This is also column 0. This is also column 0, but with a different R. This is at R1, 2, 3. So this is coordinates 0, 6 now. So it's being offset by the 6 divided by 2, which is 3 in the horizontal, which is correct. Let's give this a try. I think it'll be easier to show rather than tell. So this is returning that. We've got, what are you complaining about? Oh, this has got to return a new vector 3. Are you good? You're good? Okay. So you're returning a vector 3. This is our hex position. And in a hex map, we are using hex position over here. So let's run this and see what happens. Bam. Now we get a rhombus shape. Now, this is the one gotcha with cubic coordinates. Everything on the left edge here is that Q of 0. It's column 0. But it's offset. Instead of being that sawtooth pattern, which you might be more used to. Can I not bulk select? Oh, probably because they don't have colliders. Right? You might be looking and expecting a little bit more of the sawtooth pattern. Now, this is not hard to correct. Well, there's nothing to correct. There's nothing wrong with this. And again, overall, our math will be insanely simplified by using this. But it might be a little unintuitive that the coordinate of this tile here is 0, 10. Whereas you might expect 0, 10 to be like here. Or, yeah, here. And then 0, 9, you might expect it to be here. Now, if you're doing a game where you are showing the coordinates to the player for some reason, you may want to, in the player's interface, and in the label of these things, you may want to label them whatever it looks more correct. Like you might want to label them, this one, something like 6, 10, even though its actual hex coordinates will be 0, 10. That's perfectly okay. But the upshot of this is the math will be insanely simple to work with. And we're going to see that next time as we add in a few functions to help us calculate the distance between different hexes calculating like routing between them, and work our way towards pathfinding, for example. Although the pathfinding will come a little later. We'll colorize these tiles, and we'll also deal with the idea of our camera here, which I'm going to move our camera. Right now, it's in 3D sort of orientation. We're going to move it at a Y of 10 and a Z of 0, so it's going to be above the middle of the map, and it's got to look downward, so it's going to have a -90. So now if I hit play, we should be looking down onto our tiles, or not. Oops, my bad. Not -90, +90. Hit play. There we go. Now we're looking down at our tiles, starting at 0, 0. What we're going to want is the ability for the camera to move over and for the world, for the tiles to loop. Got a lot of requests for that. We're going to look into doing that. Doing the tile looping is not something that's specifically tied into the cubes. The cubic coordinate system, but I do say, like, ever since discovering this cubic coordinate system, it does make all the math so much better. It's so very good. Yeah. All right. Well, thank you very much for watching, folks. I'll see you next time. Thank you to all our April Patreon supporters and these Mic Check supporters. We've got Harry Hendel. We've got Yukofin, Snoopy TRB, Tiburon, Pavel Zdanov, Drazion, Gavin Power, Michael McClintock, Aaron Toibson, Greg Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marisfield Vold, Speedy Savant, Steven Stagger, Valiant Cake Fiend, Jason Yanity, Steven Bonnerman, Kale the Quick, and Neil Blakey Milner, and everyone who's watched, shared, favorited, and subscribed to these videos. Thank you so much.